Hey, what's going on? Back in my basement trying to hack up some Cortex-M4 emulation on the Quick Emulator, QEMU. About to get started, so I was just getting everything put together on my machine. Um, I'll start sharing my screen, and if you have any questions, just ask them in chat. Um, yeah, let's just get started. So today we'll probably actually do some research too on what board we'll go with. I do want a Cortex M4 if possible, but it really doesn't matter too much to me. Last time we worked, we got an example project working from this guy online from like 10 years ago. Made this great tutorial. What's his name? Should give him credit. Posted in 2010. We followed this tutorial and got his hello world that prints to a UART that's mapped in QEMU back to the console. And we saw we had to mess with we had to have a startup script and have the linker script, put that in the right location, and that would get our entry point kicked off, and that's in the C code. We learned about how to compile and everything. Running the assembler on the startup script to make an object file, running the compiler on the C file, running the linker on both of those to make an ELF file, and then to use object copy to transform that into a binary. And then we tell QEMU to run as the kernel, because normally it's running a Linux system inside it. We're running as a bare metal application. We feed in our binary. And so we did stuff like it's a headless system. There's no graphics, anything like that, so it gets rid of some of that. We did see that there's a lot of ALSA stuff, which is all for audio. We should probably have some flags to turn that off as well. They put in the RAM that matches the machine that's being emulated, and this is the machine that's being emulated. And we found in the GitHub for QEMU, there where it breaks down. Where is that? I know I have it open. It's probably this GitHub right here. That the GitHub breaks down a lot of that memory map, and we saw that the RAM was emulated as 128 meg. Then we also did some GDB and connected to that these two flags, dash little s and big S. One of them, I think the big S says to host a GDB. No, it says I think that one says to stop at the first instruction. The little s says to host a GDB server inside the emulator, and the two together make it break at the beginning. And then this is the GDB commands when you launch a GDB terminal or session, I guess. You're gonna run GDB. It's gonna give you its own terminal, not terminal, but its own prompt. And you're gonna be able to feed in commands, and so you can remote into your local host. That this -s will host it on 1, 2, 3, 4. You could go to the man page for QEMU to see that, and then you want to point at the original ELF file that we used in object copied to here, because the ELF file will have all the symbols and everything needed to properly debug and step through code and be able to know what code lines up with what instructions. And since I think that their compilation doesn't have any optimization flags, so I don't, by default, I'm assuming GCC won't optimize, and they added the -G flag, which will say to keep the debug symbols in. So this is kind of an overview of that, and I put in the git commit, the URL link. So if you want to go to the GitHub with all the source files, feel free to go do that. You go to the previous video and catch up. And today this was based on this versatile PB system, and it's an ARM 926 EJS. I want to try a different platform. A lot of the stuff I've been working on at work and stuff is Cortex-M4, M3, or A7s. And so I wanted to do a Cortex-M4 because that's the one I've been working with a lot recently. So I thought it would be good to find a system that supports that and compile for it. and take what we've learned from his, and also then deep dive into one of the machines that are defined on the GitHub for QEMU. If you can see that up on the top left, that's what am here. The GitHub for QEMU, and go to I think actually it might be this one is the one for versatile PB. Yeah. So I wanted to try to go into a TI based one because I saw TI had a machine a few episodes back, and in their machine it sounded like it supported Cortex-M3. I might have links for that up. I left all of the links up that we searched for in the last few sessions. That's the UART that they use in their emulated UART for their versatile. Let me see if I can find it. I know I had it up, so let me see. It could be one of these links. Oh, here are the two chips that are emulated in the ARM one from TI, and here's more on that. Well, we could go dive in. So these are the two main commands that we're going to use, and I'll show you why I think that the TI one is the way to go. What was this example? This was another person's that we ran into, and they're running a Linux-based system. I'm pretty sure. Yeah, they're running a Linux kernel here, so it's not really a bare metal application. So let's go in and just run some of these commands in, and let's see what the machines that Quick Emulator supports. I don't want all you. All right. Actually, let's go full screen, and let's paste this in. So here's all the machines, and the TI one was, I think, these two guys. So the LM ES2965 EVB was the one that had the better peripherals from what I remember. It had more like GPIOs and stuff, which I'm hoping they emulated all that, and we can utilize it and then really play around. If not, we could always go back to the other one if we can't get a lot of that to work. I don't want to waste too much time, but I want to be able to emulate code I can run on real hardware. So ideally, I would get like a dev kit for this, and we're going to try to find at the end of today's episode what dev kit I should buy so we could take the same code and run it on that next time. So I will buy whatever dev kit I need to be able to take the emulated code and run it. So it looks like this is a Cortex-M3 actually, and I can't even remember the differences of Cortex-M3 versus a Cortex-M4. I know it wasn't like crazy though. Yeah, let's go here. This will probably break down all the chip family. Okay, so let's think about this. So SysTick 24-bit timer. So they're the same here. This is a technical reference manual for the two. Single cycle I/O. No. And I remember there being like specific roles that each of them fall into, but I don't remember off the top of my head. Let's just look at the differences. It looks like everything lines up. So what are the main differences? Most Cortex-M3 and M4 chips have bitband and MPU. The bitband option can be added to the M0s and M0 Pluses using the Cortex-M system design kit. So there's none in this chart. Oh, here. So here's some. Okay. All right. So. Okay. Everything's very similar. Single precision floating point. Okay, so the FPU unit isn't as good. I don't really care too much. I mean, I try to avoid any floating point whenever I can, and there's always soft floating point you can leverage. Saturated instructions. Saturated instructions. Which all operations such as are limited to a fixed range. Okay, so the math is limiting, and DSP for digital signal processing. I didn't even know that. What the DSP stuff does an M4 only support. So we could run with M3. I'm okay with that. And I would like to dive more into this at some point. Never really. So going back and forth on this. This has E, probably an extended or something. They both have pipelining, which just makes it faster. Branch speculation. All right, they both have thumb instruction sets. It's probably going to come down to this stuff right here. So these are all one cycle, but a 64-bit multiply and Mac instructions require extra cycles. I don't really care about the math being anything like killer, so maybe I'm good with an M3 then. So, oh, there's a bunch of chips that do it. Freescale has them on Gen XP. I know Silicon Labs does. Yeah, there you go. EFMs. Those are ones I've worked with. Some TI ones. Microchip. Yeah. Freescale, yeah. Okay. I think we'll just run with this M3. So let's see if anyone has any examples on running an M3. So the difference of these two, let's put them side by side because I do want to just review that one more time before we dive in and choose that this is definitely our go-to. Alright, so they're both 50 megahertz. NVIC, MPU, Thumb 2 instruction set, that's all the same. Full feature debug solutions. Yeah, I guess the first one makes sense they'd be the same because they're both M3s. Full feature JTAG support, yeah. Test access support. Serial wire interface, JTAG. So it has like SWD and SWO and stuff. Looks like this one has more write cycles to the flash. Oh no, it's just bigger flash. Single write, that's all. And this has more RAM. So it's just bigger, bulkier chip. This one has 32 GPIOs. This has up to 42. Lower power battery backed hibernation module with real-time clock. Oh, so this has an RTC. So that's nice. Where did I see that? I was just reading it, right? This one, I was just reading that it has a real-time clock. Or is this one? Has a watchdog timer, 3 general purpose timers, each that provides 16-bit timer counters and can be configured to operate independently. 16-bit timers, but it doesn't say how long you can make those timers. I mean, of course, that's a detail that you'd have to look at, but where did I see that there was an real-time clock? Oh, right here. So this one has a real-time clock. That's a definitely a nice benefit to have. A 10-bit ADC. Does this one 10-bit AC with 4 analog? Okay, great. 50,000 samples per second. 1 million samples. So this one has a better. So I bet you this is just like the bulkier version of this. Like 3 fully programmable UARTs with IRDA support. 2 UARTs. I usually like to log over a UART and then use like FTDI UART to USBs so I can just telnet or screen into like a COM or a block device or character device or whatever it would show up as. SPI and I2C. Wonder if any of them have I2S for audio. PWMs. So it sounds like this one is the cooler one. I'm gonna go with this because it's nice. It looks like this is like a superset of that. Where I didn't see anything that this had that this one didn't have. And everything on this was faster. This has quadrature encoders, nice encoders, so we can do some stuff with like, I don't know, we can fool around with that later. So we'll keep that one open, but actually, what is this? Do I want this open anymore? Let's close that. Here, we'll put this at the end of it. So we'll put all of our new ones at the end. Keep it running. All right. Let me make sure audio is working because I didn't confirm that when I first got in. And the last few times it was having problems. What is this? Yeah, okay, it's working. Sound is good tonight. All right. Sounds good. So let's keep going. Keep that up. All right. We're gonna run with this guy. So let's go look for his board. So just to verify what where was that? I don't really need to go back to it. I can just go write the command myself. But it was here. We just had it up a second ago. Let's just write it ourselves. So the same way we got the machine, we're gonna get the CPU, which I think is just C. Yeah, it's just, okay, just CPU. But I think that I need to say the machine is going to be, I think it's capital M. And we're going to say it's that one I already forgot the name of because, of course. Really? I just did it a second ago. 98. So here's the machines. I can't copy paste like that. Copy. Do this, but with a capital M. Paste this machine in, and we're gonna do CPU to see all the CPUs. And that did not do what I expected to do. Requires an argument. And CPU help. Yeah, there you go. There you go. This will tell you all the CPUs that it thinks it supports for that machine. We're going to do a Cortex-M3. So, yeah, let's move the folder I was going to do. I should rename the... should rename it to an M3. Wonder how do you do that? I haven't done that yet. Let me see if I can do that really quick. Streaming Studios. Alright. Alright, so I think I updated the title. Alright, so now we have our Cortex-M3 folder. In it, I copied all the build scripts and everything we did last time. Let's just look at them really quick because I do need to see if I need to edit any of them. So we took the project root. It is going to be in this Cortex-M3 folder. The source is going to be a source directory underneath. Target's going to be a target directory underneath this project root. And let's look at the build script. And let me know in chat if you can't read anything, if the text needs to be bigger. I'll make it one more size bigger just for to make it nice. So in that, we source our environment script that we just printed out. So it's going to put all this as variables inside this world. Then we're going to delete the target directory, remake it. And that's kind of brutal. Like normally we would make that a little cleaner. So we took their instructions for assembling, building, and then we had like a problem with linking. So we did this little subshell to make it so that because the linker was not liking the file path when we had the source and all that, but that's fine. And then we did an object copy, and that's all good. What was the other script that was in here? Oh, run script. So that we just source everything And then so we're gonna have to change some of this around. So let's try to do that. I wonder if I should put in the env what our machine is and stuff, and make those arguments. So I would only have to replace this guy with the machine. I'd have to replace this guy with the CPU and this guy. So let's do that. Let's just do that. So let's just edit our env script. Oh, I didn't leave a new line at the end. That's a little bit. Oh, that's. Oof. All right. So the machine. So let's call it QEMU machine, and that's not how you spell machine. And let's paste our guy in. No, that is not it. Don't know how I lost it. Oh, it's because I had to copy it across. It's gonna be this guy, but I want it all lower. It wasn't exactly that. It had like more crud on the end. So let's just run our command again. But we want this guy, and we're gonna want a Cortex-M3. $ to get to the end of the line. A to append and move after. There you go. And then we're gonna have QEMU CPU is gonna be a Cortex-M3. Great. Now let's edit the build script. How did I not have new lines on the end of these? Actually, I don't even know if well, all right. Let's do CPU, QEMU CPU, and we're gonna do that again. What? Lame. Thought I had it. QEMU CPU U. Do I have any more takers? I do not see any more CPUs or machines. And now we're going to edit run. And open versatile. No. QEMU. And this is going to be the machine. The machine. Okay. None of that's going to actually work, but let's just try it anyway. I mean, you never know. Maybe the emulation is exactly the same. So we'll just run build. Let's see. So, LO register required. So last time we did have an issue with some of our linking and stuff, but it was just warnings. Assembler message. I want to see. So before we get too deep into this, let's just look for an example of working with the machine we're working with. I'm sure TI came out with something. So let's copy this guy. We're going to go here and look for QEM examples. So here's a README. All right, this repository is an old experiment that has been archived. Oh, that's great. Wait. They switched it over to Rust? Or is it the entire machine that's... Oh, this isn't... I was thinking this... All right. The example is in this repository. I've been upstreamed to the Cortex-M Quick Start template. That sounds interesting. We could look at that next. So supports emulation of this guy in M3 and this guy in M3. Evaluation boards. Cargo build. So it looks like we're already on the right track for that. They're specifying a GDB session different than, so the little s is the one that did the TB the GDB server, but it does a default. And all of this looks right for what we want. And how to create an MRT program from scratch. So here's one of their linker scripts. They're using some build system, probably what they were talking about, cargo. I've not used cargo. So I might just need to put in this at least into our linker script. Let's see what else is in their project. Oh, it's a Rust project. That's probably what cargo is all about. They're semi-hosting. Here's that file that they were generating. Didn't look like it did much, but it's all these probably externs that are doing most of the heavy lifting. This arm. So this is a Rust embedded project. I don't want to do any Rust stuff. Let's see if there's a better one. So we had this open in another tab. Here's the supported boards and all of. Yeah, we're using this guy. Using CMake. I've heard of Ninja stuff, but I forget. Let's dive into the ARM QEMU files. Let me make this a little smaller because it's a little hard to get around. So this had one for our Versatile, right? This is the folder that Versatile. Yeah, okay. Versatile PB is right there. We want to see if there's one for. Why do I not have chat up in here? Give me 1 second. I just need to fix something. You know what? I'll just leave. I have to fix my stream more. I can't see you guys chat if you say anything. No, don't do that. I'm trying to remember how to do this. Where is chat? Mini feed? Alright, I'm not going to worry about it. You know what I should just do is just go to my... why does it say I have it disabled? That's why. Let me re-enable chat. Alright, I'm not gonna worry about it. You know what I should just do is just go to my... Hey, why does it say I have it disabled? Okay. That's why. Let me re-enable chat. Now, why am I hearing myself? Alright, I think I fixed it now. I think it was when I changed the title. Alright, so we're trying to look for, not that, the LM. That's not a good sign. We want to find this guy. Yeah, let's search the repo for it. Stellaris. Sounds familiar too. So it's part of the TI stuff. Okay, so I'm thinking this is part of it. Does this have the other one as well? What was the other one? The S3S8811 EVB, and yeah, okay. So this is the module, the C module that they're doing stuff with. So let's try to take some notes and kind of go through this to start. Let's first see if there's a tombstone at the top. If you didn't know, this is the tombstone. Just to see if they had any notes in it. Usually it's a tombstone because it has like the name of the author, the day it was constructed, maybe the day it died or whatever. And so it's like the obituary for the thing. It's the tombstone. So let me pull up some type of note-taking abilities. Let's see what headers they're including. So some OS stuff for the emulator, errors, system buses, things like that, timers, I2C, netboard. I remember this was in the other one too. Logging. This might be interesting for the address spaces. Run state. This was for the UART. That was the UART that we were looking at before. It was like, they were like, it's one of the standard UARTs. Yeah, right here. The prime cell UART PL011. So they're using that too. That's what the other guy was using, so it's probably mapped the same. It had like a fixed register address, and it used a data register and a control register. Not a control register, a function register. I forget, but it was like two registers, and you read and write out of the same data register. And because it's emulated, it's instant. But on a real one, you have to read the flags from what the status register or something like that to know before you write the next byte into it when writing. Gamepad, interesting. That might be for the GPIO. IRQ, so it might support interrupts and all that. We want to hopefully have that. Watchdog, virtual machine state maybe, and some other stuff. So here's all the GPIO, I2C, the serial something interface, gamepad. All right. So I'm wondering. Alright, so the board info. Real-time clock. General purpose timers. And this is all the stuff for them. The timers have an alternate output used to trigger the ADC. So all these are static to this file. So a lot of this we don't need to look at. These type defs they should be for this file as well. What I need to do is look for what headers would actually expose some of this to us. But there would be addresses that we need to know about. So if you do, so this is static to this file too, right? So what isn't static? All these functions are static. Stuff for the ADC, FIFO right. What I'm doing is I'm trying to look for non-static functions, because anything static is only going to be used within this module. So I want to know what things are actually exposed to other modules, like my own code, that's going to call to actually interface with this. This looks like an important block, and there's a nice PDF there. So let's go. Let's dive into that guy. So this is a data sheet for the actual micro that we're looking at. That's the right guy, right? That's for him? Not him. Him? Perfect. So we got the data sheet up. Let's go back to it, though. I don't want to dive into that, or I'm going to never get anywhere. So it shows you all the stuff it has. Looks like all great. They didn't do an analog comparator. I don't care about hibernation and that stuff. Flash memory control. They have a watchdog timer. QEI. I don't remember that. Oh, quadrature encoder. What, I don't know what that is, but whatever. Interface. I don't know. What was this function? This is a knit. It's a little confusing, as everything is static unless I'm supposed to source this file into mine. Include it into mine. I wonder what this macro is. Right here. So this macro, I'm assuming this is a macro. This would be broken code. It takes this, and then it takes type register static. I2C general purpose and ADC. Okay. I still haven't found anything that's not Okay, here's one for the init. Okay, that's what I was looking for. So machine init. So this type init, I gotta look for where this macro is defined, just to kind of understand how this all put together. But it does this, and this inits these two machine types, and whatever this register is. This is all like bootstrapping it into emulator in some way. Just want to see if there's any more. Let's search for a type init. So those are only two type inits, and everything else is static. It looks like, and everything gets inserted through those two thingamajigs. All right, so let's search the repo for that pound define. Let me make this full screen. Get that search back. So it looks like that's how all of them interface with the project, and this is going to go through a lot. So I'm almost certain it's a pound define, so I'm going to look for a define in that. Really, you're not going to do an and, you're going to do a define or that. Can I put it in quotes? Or it's going to be literal. It's going to treat it literally. Blah. Well, we know it has to be in one of the header files unless they did transitive includes in so let's think of which one it would be in. So it would be in like an emulator one. Probably this guy. So let's just take all these, put them in our notes. And the guy we're trying to look for is all the way at the end. We're trying to look for him. And this is just reverse engineering. I could probably go look up the API for QEMU. But let's just reverse engineer it. Why am I trying to scroll? Hit home. So we said it might be under the QEMU. What was the emulator one? Or the system emulation, system emulator.h. Okay, that's just annoying. So it's supposed to be system EMU. Sys E, really? SYS EMU. Yeah, it's because they have an include folder. Include, yep. And now we do sys EMU. Then we wanted sys EMU. And this is probably going to include all these other guys. Now let's see if it has our special guy. No. I don't want to search all these. What other one's going to be? I'll try just searching it one more time. Because all these are hardware. I don't think it'll be in hardware. It's going to have a pound define in front of it. Really? Really? So annoying. Man, I can't just put pound define and somehow put this in quotes. You're going to really tell me to go look at all these spots. What's the README say? This is how to build QEMU, Launchpad. OS dependent. I'm gonna get it. It's not gonna be this. So I'm just gonna put a little space right there. Try this guy. Run state? Sure, let's look at it. What else could it be? Let me think. Actually, let me just do a quick Google search, see if... There's no module.h in here, is there? Module.h. I wonder if it's in board.h, because we weren't looking for it last time we were in there. Do I still have that open? Board. Hey, there you go. Wait, no. Defining a machine does all this, and it does that at the end. Seriously? Let me think. It's pretty interesting. It does all this when you do define machine. Was that in the other file? No, I don't even have that open anymore. Let's open another tab. Really? Hardware and board? Crap, where was that? There's a board in here? I already forgot where it was. Hardware, ARM. I forgot to pick ARM. Okay, so let's go back here. I just want to have that open so we don't have to keep worrying about the history. So what does this guy have as includes? Because we can just check what matches up. Execution memory. Cool. Host mem. Block device. It's going to be a transitive dependency, I know. And then I'm going to waste all this time doing this. VM state, no. Error, sysbus, no. This is board.h. Log. I wonder if it's in here. Disk for ARM. This is UART gamepad. There's nothing in common. All right, it's gonna be annoying. I just gotta search for it. Because I want to see how it bootstraps itself in. I mean, bootstrap's not the right term, but like how it has a hook point into the emulator. Can I like exclude a folder? Because it's probably not in the hardware folder. It's probably in some root. This is ridiculous. Instead of even looking for this, I'm just going to go look for a header for Stellaris, because honestly, I want to know what I have access to. In our last project, we didn't reference anything, we just compiled, but I feel like there has to be something. Is there an ARM folder? See if there's a Stellaris. Really? It's hard to understand, like, what headers do I use to interface with things? Do I have to use like ADC and stuff? It's STM though. What am I in right now? Hardware? So say I wanted to do something with GPIOs. If I come in here, is there going to be one for each? IMX. I don't get it. Because I want to be able to write code that I can port right to hardware. It's no point of emulating it if I can't do that. So I need to be able to work with headers that match up with the SDK for a dev kit. And those need to map into a different C files on this side or link in some other way. Or is it all going to be done through addresses? And I guess if you compile with any modules they give you for convenience purposes. Alright, so let's... Where did we leave off with building? Let me open the notepad to that Cortex folder. So when the one guy was writing his linker, he put in a section that defines the flash and the RAM, and it was pretty standard what the one Rust was doing, and it was like 2K. Oh, sorry. Excuse me. It was like 2K for flash and something. Well, we know what it said it was when we were looking here. Or I guess it was here. Flash was 256 and 64K for RAM. To remember how that block looks. I mean, we could go look at the example project. So if I go to user bin, user local bin, GCC arm share samples, LD scripts. We can just copy one from here. This is 128, so we would want twice that size. If it lines up with that, we should really go to so here, if it really lines up 256K and 64, right now we're at half and 8 times less for this. So we would double the length and double the length here and 8 times more for this guy, and make sure that the origin doesn't overlap the offset into there. Let's see one more thing though. We want to look into their code, which is here, for what size. But we did copy all that metadata into our file here. So are these the addresses of the registers? Let's go back to that code. Yeah, it's a memory map. Yeah, okay. What was the size of RAM and everything? It's probably this stuff here. Let's go look for this board info, and that'll tell us what these sizes are and addresses and so forth. So let's copy this actually as well. And look for this board info. Oh, this one passed it. Go back up. Peripherals. So what did we have for that? So we had that structure that was below. This is the one we want. The gamepad and the SSI. So that's serial something. These addresses. I don't know what DID 0, DID 1, DCs. I'm not sure what all those are. So what types of things work with this? Sysinit. It puts it into this state guy and it has the board and the IRQ. Okay. And what does that get passed to? some memory regions. So here's that offset like the other guy had, for where the system the reset goes to. So if we go to his startup code, actually it's the linker that he had. He was also offsetting to 10,000. This is 1,000. Oh no, 1,000 was for this. For I think where the stack starts. Most devices come pre-programmed with a MAC address in the user data. They're just faking out a MAC address, I guess. Here's the GPIO addresses. So that's good to have. Let's put that. Yeah, we'll put it with this. I want to know what all these are. Let's just look for this. It's the only place it's referenced. What about this guy? It's the only place it's referenced. We more care about this guy, like down below. These aren't going to be referenced anywhere. Not sure what that's about. Wait, let me see again. So where do these two inits get called? Probably in the main init. So class init on the machine. And that's part of this type info. Name, parent type is the machine. And this is going to get linked in somewhere. And this guy got his machine in it. Alright, so let's see. So that's going to have this init function. Put some metadata in. And that was getting called. That'll get called from there. I got a lot of addresses to work with. Let's go look at the linker error we have. I'm wondering if we need any of these to define like the interrupt. We should look for LD scripts inside of their repo. See if they have any in the QEMU to see what they provide us. It's almost like I should just clone this project and do some git searches myself. Is there a tree or something I can see like everything? I'll do it from here. So my VM doesn't have an internet connection. I don't know why. But magically, this exists. I magically put that on it. Oh wow, I'm lagging. Lagging badly. I think it's trying to sync between the machines and it's not doing so great. Give it a second. It's almost done. I don't know why it's taking so long. Sorry if you had some lag there. It's just down. It's almost done. Alright, it's done. Alright, stream should go back to normal. Holy files. Star.ld. One of the best wrappers. So here's ARM. Intel x86 stuff. Blah. Let's go look at this guy. Got not a real. What's interesting is his code is very similar. I mean, not similar, but he has similar sections. Like, not a lot to it. He has an entry, the main section. This starts at 0. They got the startup code first, but then they got text section, data, BSS, no read-only data. He had some alignment to it. Puts the stack in. I want to learn more about the linker scripts. I would love to do that. Just maybe next time we'll dive into linker scripts, get really good at it. Why is my internet going bad? Sorry if you're getting some clipping and stuff. So I don't know if this is needed in here to define this, but at minimum we should try to make it twice the size. So let's make this a 4. And we're going to say 256 now. Come on. This is supposed to be 64, so we're going to times 8. So, is that going to be a 1-0? I don't even want to think that. I'm just going to check myself before I mess it up. I was not going to say wreck myself. Oh. It's 2000. I was wondering why there's a comma. I was like, I've never seen that before. Yeah, it's a 1-0. That's what I thought. Alright, cool. What is my computer doing? Holy heck. The offset is so far in here that this isn't going to overlap, so I think I'm alright. Let's look for this address. I don't think we saw it in the versatile PB either, though, so I'm not really sure how this correlates to things. Don't I still have that open? Alright. Ooh. Did 0 class Fury. what the hell's ditto? Because we saw that in the structure that they had. Let's look up what this ditto is. Well, it comes up with this Stellaris. Stellaris everywhere. Let's am I in a certain commit and not master? How am I not a master? I'm certain none of this changed. So that guy. Alright, let's leave this open. And let's go like this for a second. We actually want to go to this folder. So, because I want to get the versatile. Because I never quite understood why he chose that address. And I didn't see anything that referenced it from what I remember. I think we went through this exercise last time. This address would fall into RAM probably for him. I don't know. That could be wrong. That could be wrong. Oh, that was the Ethernet. Yeah, it was the Ethernet for them. So what makes that address special? Like, it has to be defined somewhere. Come on. Why is my computer acting like this is a good computer? Like, what I'm trying to understand, is that a versatile PB thing, or is that like an ARM thing? Is that a QEMU thing? Because I know a lot of the reset stuff and how the NVIC and the nested NVIC. Oh, I know that all that is very similar across all ARM chips. Like it has to be, and there's certain map files in the CMSys that you're supposed to adjust. This is gonna be too many. I mean, the number's so generic. So let me think. Can't think of it. So when I'm linking, it says that there's an LO register required on line 3. Startup.s. Something's hanging up on my machine. Give me a second. I just want to. Chrome's memory is so ridiculous right now. VirtualBox is doing good. Yeah, Chrome is just going all haywire. 2.5 gigs of RAM. Let's try to put this global reset back in. I'm gonna have to kill my Chrome and relaunch it. Someday it'll give me back my mouse to be able to do stuff. My CPU is at 70. My memory's at 60. Why is it like everything running slow? How's my OBS is doing 40% of my GPU. So I just want to see if putting this back in, that'll fix this. I'm just opening up my Chrome again. Trying to open a new window. I'm not having a good day today. Without understanding it, I'm just going to add this to the .s file just to see if it corrects it. I hate doing that, but really. It didn't say error, but it said multiple definitions. Did it actually compile? Okay. Yeah, it did.
Oh, no, it failed on the linking. Okay, so let's just edit that and we'll turn off the global. It gave like an error last time saying like couldn't find it. Yeah, like not defined, so I'm just gonna do something. Didn't want to do that. I want to go into the bottom left corner. Don't you hit left and bottom? Okay. And I want this guy. No, I want the other one. This guy. We're gonna hook it up to the GDB server. Target. Remote. Localhost 1234, I think. And then target. No, file is target. Actually, let me quit this for a second because I'm in the wrong folder. Oops. Yeah, that caused it to crash. Yeah, I need to go in this Cortex-M3 folder. Alright, he's running. So I should be able to hook up with GDB. Doesn't save any type of state. So yeah, we're just connecting our GDB client to the server running in the emulator. And then we do file, and then we tell it should be in target / oh cool, it lets me autocomplete the test elf. And I should be able to just do continue. And then it said, I hard faulted because I did not map things properly. There's a core dump. Oh, why did my QEMU machine not work right? I don't think when I ran it, it ran it with this machine properly. Reset. QEMU underscore machine. QEMU underscore machine. What? Okay. Why didn't it put it there? What? It did that time. Oh, this is just the shell saying that thing errored out on that line. All right, so when I'm compiling, I probably need a lot of these flags. Yeah, we didn't even edit any of that. Let's bring up the build on this thing's. Even Notepad is not running properly. Oh wait, I don't want to do that because I don't want to lose this. Shit, it's all of our notes. Notepad++, if you lose all my notes, I'm not going to use you anymore. Better restore that crap. What? Now you're going to make me take a download too. Hey. Can I cancel this download? Can I use this while it's downloading? Alright, cool. I'm going to save this before we lose it. Oh, my slowness. Okay, why does my view not have the chat in it? Really have to do all this right now? Alright, I got my chat back up in case anyone says anything. Run, yes, run. Come on. Yes, I always want my windows off the screen. No, nobody cares about what changed. Can I make this new root? Like, why is that not an option? Make it the new root. Maybe it's one of these buttons. Oh, wow. This is trash. I only got like a $3,000 computer that I hand built, so I mean it's old, but oh, I said expand everything. So let's see. I just noticed it forced me to save this, so this is probably not going to work. But I mean, it might not hurt anything. Oh, it didn't even save what I had. No, it did. But I never updated this. Like, this address is all wrong for the code that we're doing. So that's one thing I should have changed. Let me actually just do that really quick. So if we go to our notes, where's UART 0? There's 3 UARTs. Is there a 4th somewhere? Let's just write it to this one and hope that that's the right one.
So that's at least like semi-accurate. We can go look at if that maps to what we expect it to be. Because that could just, I mean, that could be it all by itself. The RAM is also 128, and we think that we should be emulating at 64, so let's edit the run script for that. What else? Like, I keep losing track because things just keep sucking. Alright, so that's running. Oh wait, I didn't build again. What am I doing? AX. Okay. Reset. Build. Really? Different outcome. It just says the program is not being run. Was it not able to attach? Remote debugging using that. A program is being debugged already. Are you sure you want to change the file? Yes. Load new symbols from that guy? Yes. Reading symbols, cool. And then I say continue. Alright, so something different happened that time. I feel like I did those steps and I just did them again and then it changed. Trying to execute code outside of RAM or ROM at this memory address. So why? This usually means one of the following happened. You told to execute a kernel for the wrong machine type. Okay. Let me think. So you didn't give the kernel or BIOS file name at all, except a ROM full of no op instructions until it fell off the end. Let me see what I did for run. Because I bet you might run. I should really put the CPU in. QEMU. Oh, I wonder if I have to. I should have to say. Well, no, my machine is. Let's go. Let's open up the env. My machine is this guy, so that should be all right. Let's try to run. All right, I got the same thing again. Okay. What about when we build? We were talking about editing the build, and we were like, we're building, but we barely set in the options. Like, we didn't even tell it's a thumb instruction set and stuff, and those are definitely needed. So, I'm trying to remember all the flags. Like, we should have soft floating point, and it sparked my memory because we were looking at one of the links, and I was like, oh yeah, we need like the stuff for I could probably just jot something down really quick by just reading GCC's man page. Come on. I just want it to be long. God. Okay. So I'll just write flags as I go and then I'll copy them in after. So we definitely want, I mean, that just says compile preprocessor. I always get them all confused. Actually, I think this is preprocessor, this is assemble, this is compile, and do all three. And then linker something else. Out file, language doesn't matter. Verbose, version. We might have some spec stuff that we have to do. This will make a map file, and I kind of want that actually. Does he do that? Does he spit out a map file? Yeah, we should probably spit out a map file. Oh, that's prefix map. Yeah, I think that lets you like put things in other folders. Like, where are the ones for semi-hosting and for the soft floating point and for what am I thinking about? I know there's some really important ones. For thumb, there's mthumb. Like, there's that. Let me just look for thumb. Yeah, mthumb. So we should have mthumb in here. I don't know if it would go for the assembly as well. Yeah, it should. I mean, it doesn't seem like... I don't know why you wouldn't have mthumb in there. What else would there be? The thumb instructions are the soft floating point, the semi-hosting, the nano spec. That's one. CPU. Let's look at one of the example projects, because I know they had a lot of them. So user local bin GCC ARM, and we're going to go to, I think it's not the sample app, share sample. What is it? GCC sample and source. Look at the QEMU. Make file. But it really won't have much in here. We gotta go to the main make file. Yeah, here's some of the ones I want. The CPU, we already have that, right? Yeah, we have that right here. mthumb I just added. So those are the Arch ones that we should... I was forgetting about the mthumb. Optimize for size. I don't care about that. Link time optimization. I don't care about. These two are good for organization, I think, and optimizing size. This makes the map file. This should actually be done during linking. Actually, these might be linking ones too, actually. Yeah.
Let's just try this. Oh, did I say no spec? I want nano. Sorry, that's for something else. I want nano spec. Alright, let's see if it builds. Really? Maybe it's just because it's the assembler? Has to be at the linking step. I don't get it. Why does it not understand it? Unrecognized option. I'll just take it out. Is there really no good way to snap it properly? Or am I not understanding? Why is it trying to execute code all the way out here? It has to be the startup stuff. What if I just make this 0 for a second? Wait, it failed to compile? Linker.txt LMA overlap section startup. What is overlapping it? Text section is after it, isn't it? Let me get rid of this. I think you can comment it out
it's today was like a non a usual day for me to stream, so I'm thinking I'm gonna call it here. I'm having problems with the machine. We got kind of far. We learned a lot about the system. We chose what we want to go with. So I think what we're gonna do now is just let me switch over to just chatting, and we just talk. All right. So I want to buy a dev kit. I think I'm gonna get this Stellaris one. Let me pull up the chat and see if anyone's saying anything. So, let me look for I can actually share my screen again for a second. Because I do want to. I just hit the wrong button and now I'm going to. No, Blizzard, go away. Where's their launch pad? So I think we can get a Stellaris launch pad with one of the modules for it. Launchpad's $13. That's like cheap as crap. Where's like all the modules and stuff? I actually feel like I have a TI launchpad somewhere. I mean, I could always get a new one though. So where's the modules for it and stuff? Because this would just be the programmer, right? There's USB connection, some I/O buttons, switch. It looks like switch 1 and 2. There's a jumper. So Launchpad Evaluation Board is a low-cost evaluation platform for ARM Cortex-M3 based microcontrollers from TI. The design of the Stellaris Launchpad highlights the microcontroller with a USB 2.0 device interface and hibernation module. Wait, it doesn't. Modules don't sit on top of it, or is the micro built into the Launchpad, or are these just part of the Launchpad? Also features programmable user buttons and GPIO LED for custom applications and whatnot. Let's look for the chip that we're doing. So where are the modules for this guy? Not recommended for new designs. Replaced by this guy. Similar functionality, but is not functionally equivalent compared to it. This product is an M4 with comparable peripherals and higher performance. And this one's also similar, but broader peripherals and higher performance. Let me see. One's IoT, so it's automatically more expensive because of that name. And some security encryption and stuff. Yeah, it has an Ethernet PHY and everything. This is like overkill. What about this guy? I mean, that's all cool and everything. We can always switch it over. This looks better. Design and development. Yeah, show me what. Here's a launch pad. What I don't get is they don't have dev kits with pluggable modules. You have to buy a launch pad for each chip that you want to develop with. It's kind of weird. Oh, here's an eval kit. What does this one do? All right, so I'm gonna do some research on which one I want to get, and I'll buy one of these and have it for next time so we can get it working. With I probably won't have it for Sunday, but we'll get everything ready Sunday, and then we'll have it for maybe Tuesday if I'm lucky, and then we can try to emulate it. Once we get the emulator running, then we'll get it working on hardware. Then we'll get some UARTs and I2C spies. I'll try to get a scope going and see it on the real stuff. And yeah, we can switch it back off of to just chatting again. So we got a little bit farther. We learned about the chips and dove into the QEMU hardware folder. Learned a little bit, grabbed some notes on how the memory's all mapped and the registers and everything. And so I think that's good notes for next time. I might do some research on just understanding where there's documentation on some of this stuff, because I didn't really do any searching on that. I've been just trying to reverse engineer it myself for right now. So next time we'll hack in our basement and try to get into some more of this. And it should be fun. Like, we got the old other example project working, and we messed with it a little bit, but now we're gonna do it for one closer to what I wanted to do, which was M4 or an M3, and shouldn't be long. So remember, till next time, hack a bunch in your basement and have fun with it. Talk to you later. Till next time.